Shrija and this is a demonstration of Coursework to serverless architecture. This is my task 1 function that stimulates environmental data from 20 sensors. The function is stateless and generates new temperature, wind, humidity and CO2 readings on each HTTP trigger. Once the function is deployed, we can get the function URL from the get function URL tab and enter the URL into any browser to generate 20 new sensors that will be stored in the database. Here we can see 20 more rows have been inserted into the database. We refresh it. Now it's 1460. We refresh. 20 more rows have been inserted. Now we set the parameter of number of records equals to 2. 40 more rows have been inserted, and on the database when we refresh, we see that the total rows has been updated to 1581520. This shows that the database is storing the data correctly from the HTTP trigger. This is my task 2 function which reads all sensor readings stored in the Azure SQL database by task 1. It calculates the minimum, maximum and average values of temperature, wind, humidity and CO2 for each sensor. This function is also HTTP triggered. When I run it using the get function URL, it retrieves all rows currently stored in the sensor data table, groups them by sensor ID and returns the computed statics as a JSON response. Currently you can see here that these are the number of rows that are stored in the sensor data table. The same number of rows are reflected here when the function is HTTP triggered. And here below, the function returns the minimum, maximum, average values for each parameter. This is my task 3. Here the same data generation logic that was manually triggered using HTTP request in task 1 is now fully automated using the Azure timer trigger. Here we can currently see that these are the total number of rows stored in the database. This function runs on a fixed interval of every 5 minutes and automatically generates and stores new readings from 20 sensors into the sensor data table without requiring any human interaction. Here we can see that the last set of 20 new sensor data have been generated at 12:55. Time is currently 1, and when we run, a new set of 20 sensors have been generated at 1, and the number of rows have been increased by 20. This is my task 3. It completes statistics automatically whenever new data is added into the sensor data table. Since SQL trigger execution failed despite many trials, an alternative method was chosen to complete this task, that is using automated HTTP triggers that is invoked directly from task 3A. This solution achieves the same behavior as SQL trigger. From task 3A, we know that the data is getting generated every 5 minutes. Therefore, the latest data that was inserted into the sensor data table was at 2:10. Now here in the sensor stats table, we can also see that the